Amazingly, you can use code which other people all over the world have published online. And to do this, you can use a package manager. So a package manager, what is it? Well, a package manager handles getting the source code from off the internet and putting it somewhere that you can access from your code. If you want to install software to run new terminal commands, then you should use a system package manager. If you're on Linux, that'll probably be apt, A-P-T, and if you're on Mac, that'll be brew. And these package managers are language specific. So to install third-party Python code, you'll need to use a different package manager, specifically a Python package manager like Conda, or another package manager for Python, which works in pretty much the same way, is pip. And even though pip and conda are Python package managers, they're run from the command line. You can also write your own code that can be imported into your programs. And we call any Python file that contains anything we might want to import a module. And we can import anything that's defined in Python from that module. Classes, functions, or really any variable. And usually, if a directory contains several modules, we call that directory a package. So let's see some examples of how to import in Python. Importing modules is pretty straightforward. We use the keyword import followed by the name of the script or the module that we want to bring into our code. So in this case, we're importing a module named example module, and you can see it down there. A key thing that you need to understand about imports is that they don't bring specific parts of the code in. An import will run the whole file that you're importing, not just a specific part. That's really important, and it's an easy mistake to make. So before importing the module, let's check what's inside here. So yeah, you can see there's a function, and then there's a print statement, and then I've got two variables defined. And that's what I'm going to import into my notebook here. So if I import that, you see this print statement's been run. And that's a clear example of the fact that I've just tried to import it. I haven't intentionally tried to run any of the code, but this whole file gets run when I import it. So this print statement's been run right there, and that's why it shows up in my notebook there. And now that we've imported that, you can use the functions and the variables which are defined inside that file. And to do that, you simply use the dot operator to reference the function or the variable which is within that module which we just imported. So running that, I can see that both of those things seem to have worked. I've got X and I've got the print statement. And the module prefix can help distinguish the variables that we've got in our code and the variables defined in the module that we're importing. So there's nothing stopping us from having the same name for a variable inside our file and one of the ones inside the file which we're importing. We don't have to worry about those name clashes. So for example, you can see that if we define a new variable y in our notebook, it's not going to replace the value of y that we import from the module. Cool, so there I've defined my variable y, I've imported my module example module, printed its variable y, it comes out as foo, and then I've printed y again, and my y is still equal to 50. So one thing to take into account with imports is that after we import a module, Python will assume that it's already been imported, and if it's already been imported, it won't run the file again if it hits another import statement for the same module. And so that's an exception to the rule which I said earlier, that an import statement runs the file being imported. We can see that there's no output now, so we need to restart the kernel to basically tell Python, wipe your memory and forget that you've already imported it. And that's because we're working in a notebook and the imported objects are stored in the Python notebook memory. So if we want to import the module again, we need to restart the kernel. Now that we've restarted the kernel, we can import the module again. But instead of importing the whole module this time, let's just import a variable in that module X. And you can do that using the from keyword. The whole module has been executed, but now we get the value of X directly. So remember, even if we try to only import certain parts of the code, the whole module is still going to run. All of that file is still going to run. But now that we've imported a specific part, any other variables which ran in that file, they're not going to be accessible. It's also worth mentioning here that modules and variables within them can be imported with a different name than what they've actually been defined as by using the as keyword. And you typically do this if your import has a long name, if you know that you're going to be writing out that import name a lot, or if you're specifically trying to avoid a variable name clash. And some libraries, like NumPy and Pandas, which are both really common, have some canonical import aliases, which basically just everyone uses. So if you're importing those libraries, you should use them too. So now I'm going to look at a different module, which I'm going to import. It looks basically the same as the other one, except for one thing. And what that is this if _name == main block at the bottom, the if name equals main block. So this if condition is something that you'll see all over the place and that you should use in most of your scripts. It looks complicated, but all it means is that the code within the block will only run if this file is run directly, and that is if this file is the main file. And that's what the condition is checking for here. So this $_name is a built-in variable that's always available, and it stores the name which Python stored for this file. $_name is a built-in variable that is always available, and it stores the name which Python stored for this file. So what's Python calling this file right now? Python calls the file which you run directly main. And when I say runs directly, what I mean is that I'm running it either in the notebook, in that case the notebook itself will be the main file, or I'm specifying Python to run this file directly from the terminal. So now if I'm to do the same thing, if I run this file, example module _2, now you'll see that it prints this, and this is only executed if this is called directly. So here, this is an example of me running the example module 2 directly. When I'm not running it directly, what I probably mean is that I'm importing it. So if I'm in the notebook, like I'm going to show in a sec, and I import this module, I shouldn't expect this to show up, because that would be an indirect import where this file is the main file, and hence the name of this file is not equal to the main file. So once again, the code inside the if name equals main block will only be executed if this file is run directly. And it's going to be skipped if you import it into another file, which would be running the file indirectly through an import. So here I'm going to import that file, and the main file here is the notebook. So when I run this, I don't see the line which was telling me it would only be executed if this file was run directly, because this file wasn't run directly. This was the file that was run directly, and then through that main file, I indirectly imported this and ran that file. So the if name equals main block was not run. And that's really important to understand, because like I said, it looks complicated. Loads of people spend ages not really understanding what it means, but like I said previously, this line here, all it means is that only run this code if the user runs this file directly. So why might you want to use that? Well, one example might be that you have a file that has lots of useful functions for, say, processing data in, and you want to import these functions into other programs. But when you run this file directly, you want it to run code that puts all those functions together and runs the data processing pipeline. So you'd run that code in the if name equals main block, and that means it wouldn't run the whole pipeline when you import things from that file. It's important to know how Python will look for imports. Python will look for modules and packages in the directories included in what's known as the Python path. You can see your Python path in the terminal by running echo Python path, and that shows you the environment variable which contains every directory which Python's going to look for things it can import from in order, and they're each separated by a colon in this case. So that's the first place it's going to look, and then it's going to look there. And you can also access it in Python by importing the sys library and running sys.path, which is a list. And so when you try and import something, Python will look firstly in the directory that you're currently in. That's always the first place it looks. And then it will go through the list of directories in the Python path in order. And when you install new packages, your Python package manager should save them into one of these folders so that Python can find them when it looks for those modules. And just note that, as I've just showed there, these directories will vary when you move between virtual environments. So in my VS Code right now, I'm in a particular environment which was different to the default one which my terminal was using, which is why those Python paths are different. So make sure that when you import packages, you're in the right virtual environment. So you can only import Python files into Python. not other types of files like text files or image files. But you can use the built-in open function to open any file type. It returns a variable that has methods for reading and writing to that file, amongst other things. An easy mistake to make is not closing the file after you're done with it so that it continues to occupy memory. And this is known as a memory leak. If you're opening tons of files or just working with limited memory, this can cause the system to slow down or even crash. So let's see an example of that happening. Here I'm going to open 10,000 different files and I'm going to forget to close all of them. So I run that, get an error, too many files in the system. But you could avoid that if you properly managed your resources. What we should have done is close the file, and you can do that by using the .close method on that file object. So here I've got exactly the same code, I'm opening it, and then once I'm done with that file, I'm going to close it. But closing the file is easy to forget, and it takes up more lines than the best way to do it does. The best way to do it would be to use what's called a context manager. They start with the Python keyword with, and then they expect a certain object, like what's returned from the open function, to be assigned to a temporary variable which follows the as keyword, and then a colon to indicate the start of an indented block. The temporary variable can be referenced inside the block, and we call everything in the block the context. What's key about the objects that can be used here is that under the hood, they have magic methods defined for how to enter the context and how to leave the context. When I say here, I mean to highlight that. And in our case, entering the context opens the file and exiting the context closes the file. So we don't have to remember to close it manually or even write the code out. So context managers are used all over the place for when you want some temporary behavior, and some other examples might include making and closing temporary database connections, creating and deleting temporary folders, or running a machine learning model in a certain mode.